We're excited to introduce our next speaker, Hemanth HM, Senior Staff Software Engineering Manager at PayPal. Hemanth is set to present Supercharging Your Creativity with Google's PaLM API, Makersuite, and Langchain.
Hello, everybody. Good to see you. Yeah, supercharging your creativity with PaLM, Makersuite, Langchain, and maybe a bit of Llama Index too. If you think you're in the wrong room, this is the right time to change your mind and stay, because this is going to be some fun ride here. Yeah, that's me with AI in the PaLM. I'm a senior software engineering manager at PayPal. I'm a GDE for web and payments domain. I'm a TC39 delegate too, working on some of the latest JavaScript features. You can find me at h3man.com or tweet to me at Hemanth. PaLM 2, Google's next generation language model. As we speak, we also know there are rumors about the next generation Gemini model that might come up. So PaLM 2 is the Google's next generation large language model. It kind of beats the previous PaLM. Of course, that's PaLM 2. It should be more performant in some benchmarks. It also beats GPT-4 in few areas. These are different benchmarks, and there are some of values that we have. It has these many parameters. No, these many. Well, yeah, 540 billion parameters, and it makes it super powerful in terms of translation, understanding multiple languages, maybe even cracking a dad joke, or writing Python code for me, or solving math puzzles and things like that, right? Roll the video. OK. It's based on a pathway model, where a single model that's capable of having multiple millions of tracks. It's based on that model, a paper from Google. And the crux of PaLM is pathway, and hence PA in pathway. It's also great at medicine. We have MedPaLM, which the passing rate of 67.2%, where the average score is 60. So it's kind of better at grades, right? And there are a few examples where it can read your CT scans and MRI scans. And in this example, it's kind of giving an X-ray to it and asking, hey, can you do a quick diagnosis on this and say if everything looks fine? Is the heart OK? Is the lungs look fine? And things like that. It can quickly answer. That's MedPaLM. I think we had another video there. OK. We also have the SecPaLM, which is security. The model is kind of fine-tuned for security, where it can kind of help you with some of your security vulnerabilities on the security AI workbench. It helps you to kind of catch some of the bugs before it's on production. It can run scans on your code and also keep listening on what's happening on live and alert and all of that, right? LLM. We kept hearing about LLMs in different flavors and how it's useful for multiple folks in various talks. To break it down again, it's LLM as in large language model, large because it's been trained on a large corpus of text, and language as in it understands NLP. It can kind of understand human conversation, and model because it's been trained on that large data, and it can learn using AI systems. Again, LLMs can be broken down in terms of the definition, capabilities, the training process. May it be like the supervised, unsupervised learnings. And when we know the applications are multiple, may it be content generation, data analysis, or helping you to be creative, and probably just having conversations, chatbots, and things like that. There are some limitations. We all know about hallucinations. We did see a few examples in previous talks. And it can also kind of interpret errors. And sometimes it can like blatantly and confidently say, this is what it is. Like ask a program or help to fix a bug. It says, this is the solution. But if you go and try, it's definitely not the solution. So these do come with LLMs. And the PaLM models are basically categorized into Chat Bison, Embedding Gecko, and then we have the Text Bison. We also have the Unicorn. With Text Bison, you can do code generation. You can do text generation, text editing, and all the text-related stuff. With Chat Bison, it's more about the conversational model, where you can have conversation with the bot. It can have some context. It can remember. It can have a chain of thoughts and respond to what you asked previously. And Embedding Gecko is for all the embedding processes that we have. You can have a document, and you want to create embeddings out of it, and then have a conversation with it, and things like that. So the three main things that come in here to the picture here is we have the PaLM AI, we have the Makersuite, and the Vertex AI. We did hear about Vertex AI in the previous talk, and here I'll be covering about PaLM AI and Makersuite. I was happy to be in the early previews and closed beta experiences of Makersuite and PaLM AI, and I'll share some experience that I have with those APIs and the Makersuite. So PaLM API is an experimental API to converse with Google's LLMs. It's platform agnostic. It's not available in all countries. There is a list where it's available and where it's not. And Makersuite is more like no code. You can just go and play with LLMs. And we will be seeing a quick demo on what Makersuite is and how it could be useful. And Vertex AI, of course, is more like the enterprise edition, where you can fine tune. You can also experiment with a bit of fine tuning on Makersuite too, but Vertex AI gives you the full suite and more of an enterprise, which comes with a cost. PaLM AI is kind of capable of coding. It's efficient. It can answer reasoning questions, and it's multilingual. We did see in one of the talks where they were having a use case where there were multiple languages happening as a conversation in the chat, and they were seeing few challenges. PaLM can be a good candidate there. Ideas. Where do ideas come from, right? I was discussing about this over lunch too. I think we have Vega here. Like we were having a conversation with a few of the folks, and where do ideas come from? There was a good paper where they did a lot of study on where do ideas come from, and they said, hey, if you go to the medieval eras, right, people used to kind of sit in groups and probably drink and discuss, and there is a philosopher, a mathematician, and a chemist, and there is a lot of cross-pollination of ideas that's happening, right? So I would probably see LLM as more like that place which has all this knowledge, and you can kind of get creative with exchanging ideas and thoughts and kind of correcting your thought process or spinning out a new idea and things like that, right? So LLMs, we know it's everywhere, starting maybe from supply chain logistics to health to education to finance, banking, content creation, and all of it, right? So these are different various areas where it's already created impact and has been helping us to get better where we are. Demo, please. And all these images are, of course, created with DALL-E, and it's gotten better with spellings, and it is even getting better with counting fingers and likes. Roll it, please. Yeah, this is a Vercel app that I've placed. You can go to palmai.vercel.app, which gives you a cross-origin API where you can just request, and it works like a chatbot. You can have conversation. You can pass. You can create content with it and use it in your web applications and likes. Roll it, please. OK. This is an example of PaLM API using the same Vercel API, Vercel app that I hosted. I created these two apps. Here it's rather using the library directly rather than using the proxy for the API. One is with the Streamlit. The other is with this Guardio from Python. I'm just playing it in 2x so that you know how the chat conversation happens. So that would be a very good start to just build an hello world chat example and hosted it on my site to html.com/pamchat. Roll it again. This is an example called SpexPlain. So if you're into reading language specifications, sometimes it can get very complex, right? It uses a lot of jargons. The previous slide, please. Sometimes it uses, can we go to the previous one? Yeah, sometimes it uses a lot of jargons, and it might get complex to understand the specification. Previous to this. So that plugin uses PaLM, and it basically takes the section of the specification and then explains what it is. The other, can we go to the previous slide, please? Yes, yeah, thank you. Yeah, so when you go and hit explain there, it would take that code block of specification and explain it in explain me like 5 kind of a scenario, right? And the next video is like a therapeutic diet where I'm giving an example of an age of 30, weight, and so on. So I'm saying allergies, mushrooms, and tofu, and conditions like anxiety in pots. And this would go ahead and create me a diet plan which would say, hey, this is what you need to have for breakfast. This is what you need to have for your lunch and dinner. And also puts a caution at the end saying that, hey, this is just a plan. Please consult your dietitian and things like that, right? So you can imagine building apps like this with just customized prompts. And we all know about GPTs. That's kind of creating a new era, which is very much similar of how you could create apps here. That's more of like chatbots being customized and deployed on your domain and likes. Roll it, please. Yeah, this is another example of summarizing a book. Here I'm giving a book called Outlier. which kind of goes and summarizes the book. Roll it, please. Summarizes the book, and it takes the book's name, and then because it's already read the book, it can go ahead and summarize it to me. I would say, plot out the main characters, plot out the summary, tell me the genre, or probably I could also tell it to give me some actionable items from the book and how I can apply. Roll it, please. Here's an example of the bot on the CLI. I'm using the same API, but I'm running a command line bot. And it says, I am just saying hi, it would say hi, and it would say, give me a dad joke, it gives me a dad joke. Or if you can even pipe an error to it, say if you're running a code and you want to do a log processing and things like that, you can pipe an error to it or pipe that log and ask what needs to be done. I'm also trying to ask it, what's the weather like? And we all know it could pick up its location, and it's not bad. It picked up Mountain View there in that example, based on probably where the API was running. Roll it, please. Langchain is that framework that kind of gives you an abstraction over LLMs. It makes it super easy to plug multiple variants of LLM, A/B test, and it has all of these features, made from model I/O, from prompts to LLMs to output parsers, chat models. We have retrievers, we have vector stores and retrievers, document loaders. Of course, we have chains. That's why it's Langchain in the chaining. And we have agents, evaluation, and memory. We'll be covering all of this in some of the live demo, except for evaluation, evaluation is more like doing an A/B testing. If you have two LLMs, you want to test and see which is better and why. You could use Langchain to do that. Roll it, please. And of course, Llama Index is a beautiful framework. We have the co-founder and the CTO in the room here. So I'm not going to talk about Llama Index much. We'll probably see a couple of demos. And some of the jargons that you need to keep in mind here is things like top P, top K, token limit, max response, stop sequence. These are the things that we will be talking about in the demo. It's pretty simple. If you see top P is P for probability, you know that's the threshold probability that it has, and top K is the number of tokens that it can select. And then I think the slide kind of switched here. So these are some of the jargons, and don't worry, like when we get into the demos, it'll get easier to understand them. Now to the actual demo. I'm going to switch to my other laptop. All right, cool. So I did speak about Makersuite at the beginning. Let's quickly see what Makersuite is and how it can be useful. If you go to makersuite.google.com, it will show you a prompt where you say, do you agree to the license agreement? You agree, you get in there. And then you go to text prompt, data prompt, and chat prompt. Like these are the different variants that you can play around with. Let's say probably pick text prompt. I click text prompt. I'm picking a sample prompt here. Say summarize the paragraph. All it does is, hey, is the text OK? Should I zoom in a bit? My command ++ is not working though. Yeah. So you could summarize the paragraph. I'm giving a huge paragraph here that's text, and then I'm saying, hey, this is how you would summarize, and then I'm giving a text block again, and I'm expecting it to summarize. So when I go and hit run, it would go ahead and summarize. And the things I mentioned here are in the settings here, where you can set the output length, you can set the top K, top P, and you can also set the temperature. So if the lesser the temperature, the less creative it is. Higher the temperature, the more creative it gets. And you can select the model you want. I have one more root word called Dhatu list here, which is a model that I've trained. We'll see that in a bit. And then you could also go to here in the text preview and see how it looks. You can get the token count and likes. The interesting part here is you can click on get code, and then it will show you the Python code that would solve this problem. Now you could give a text as a summary and then go ahead and solve it. Also gives you JavaScript, and you can also open it in Colab if you want. So that's with text prompt. Let's quickly see an example of chat prompt. So I go here and I click on chat prompt. Here's an example with chat with aliens. We give the context there, and I would say, hey, I'd like to visit you. What should I do? Then it will go and respond on as if it were an alien and it's having a conversation with us. The same thing applies here. You could click on get code, get the code you want, and then go ahead and execute it and play around with it. So it did respond. The best way to visit Europa is to take a spacecraft. OK, that's interesting. And then we have data prompt. Data prompt, again, is useful in the sense, suppose you have, say, an Excel sheet with a lot of content in it with just 2 columns. And column A, in this example, column A is a word, and column B is an opposite of that word. It could be anything. It could be word and definition, or whatever data you have. It could be a data prompt here. In this example, say, it's kind of training the model here, right? We are saying, we are giving inputs as wrong, fast, give me a random value, maybe light, right? And say run. What it's doing is, based on the example, it knows how to reply. Now it's saying for wrong, it's saying right. For fast, it's saying slow. For light, it's saying dark. So again, the same thing applies. You can go here and also click on tune. When you go and hit on tune, you can save that. It will probably throw an error because it needs more input values, not just like 4 examples to tune on that, right? So that's data prompt. You could go to model, and you could tune a model. In this case, you could create a data prompt or opposites. And here I have an example. After it's tuned, it will take some while based on your data. After it's tuned, it would show this value, like what is the number of batches it took, the total run time, and then the number of examples it parsed, and that you can use it in your data prompts. Now let's go to the code. This is the code that was generated that just we saw a few minutes back for summarizing the text. Let's run this. This is JavaScript example, which is using Google AI generative languages module, and it takes the text service there. For the text service, I'm passing the API key. It would go ahead and generate the result, saying that this is the safety ratings, and this is the output, that it summarized that block of text, right? Here's another example I have. In this case, I'm using Langchain's LLM, Google PaLM, and the Google PaLM model here. And in the same applies here. I pass in the parameters. I pass in the API key, temperature, max output, top K, and all of the settings. And there are certain calls that I'm making to the model. In the first case, I'm saying, give me 10 quotes, one-liners from the book Man's Search for Meaning. It's a wonderful book, Viktor Frankl's. And also, I'm saying, like, give me JS code to detect leap year. And then I'm saying, convert that JS code to TypeScript. And then I'm saying the most classic example of computer science is, what do I name the variable, right? So I'm asking it, what do you name a variable which stores the form data as a JSON? Give me like 5 different names, all right? Let's see how it does. I think it's time for a joke when it's running. There are 4 hard problems in computer science, right? Naming variables, cache invalidation, and off by 1 error, right? So here's the output. It has all those 10 one-liners that we asked for. We must never forget that we are not alone. Wow, that's nice. And then it gave the JavaScript code for leap year. Then it converted the same code to TypeScript. It gave me the variable names. That's form data, JSON, form data object, form data as JSON. So that's pretty decent, right? Now let's get into the crux of it on PaLM 2 and Langchain. We did see a quick demo on what are different capabilities that Langchain provides, and let's see the example. I have executed the dependencies here just before I started the talk. I'm installing Langchain and Google Generative AI, and I have stored my API key here. I'm user reading that API key and setting it as PaLM API key. Then from Langchain LLMs, I import Google PaLM, and then instantiate Google PaLM with that API key and pass the temperature as 0.5. I get the LLM. Let's say, give me a few names for new vegan restaurant. So it goes ahead and gives me a few names, like the Loving Hut, Peaceful Planet, Vegan Soul Food, fantastic. So that's how easy is it's to use LLM. I can just import whatever LLM I want. If I want OpenAI, or I want to use Claude, or depends on what LLM you want. You want Olama, all of that is possible with Langchain LLMs, and it follows the same pattern. You just instantiate whichever you need, you pass the API key, and then in this case, you do predict. The other interesting part is prompt templates. In this case, I'm importing prompt templates from Langchain. So what's the use case of prompt templates? I'm using the same example here. In this example, I'm saying you behave like a vegan cook and give me vegan recipes. But make sure that you avoid certain ingredients because I'm allergic to that. So that's kind of a prompt sitting there which says food allergy, right? It's like a placeholder. I would go to the vegan cook. I say prompt.from template. From this template, I created a vegan cook. From vegan cook, I say format food allergies as soy and mushroom. And then let's see what the prompt would be, right? Vegan cook is not defined. Great, because I didn't execute that shell. Yeah. Now it has replaced that food allergy with avoid soy and mushroom ingredients. Now we can go to LLM and predict and pass in the prompt. It will take a bit, and it should come back with a recipe where it doesn't have the ingredients that I mentioned. So here's some delicious vegan recipes that are nutrition easy to make, and it will go and explain. It's explaining about vegan chili and things like that, which is good. I don't really see any reference to soy or mushroom. That's great, right? So you can think of this template as a reusable template where you can start passing different food allergies and start creating different recipes based on users' preference, right? Chains is a very important concept of Langchain. A chain consists of links, which can be primitives of other chains. So you can have chain of chains, or the primitives can be like prompts, LLMs, utils, and tools, and things like that, right? So from Langchain chains, we import LLM chain, and then we pass in LLM to it, pass the prompt as vegan cook. That's the prompt that we just cooked. And then I say chain.run soy and mushroom, and it should come back with a similar result. But in this case, I'm using chain rather than just using a bare template, and I'm chaining it. Here's another example of a joke template. In this template, I'm saying, give me a joke on subject, and the input variables here are joke and subject type. And then I say LLM chain, I pass in LLM, and I pass in the prompt, that's the joke template. And then say chain.run, my joke type is dad joke, and subject is life. So let's see whether it throws me a dad joke on life. What do you call a deer with no eyes? No idea. Not bad. So this is a bit of an like an older syntax with LLM chains. You can use the LCEL. Any guesses on what LCEL is? It's Langchain expression language. So instead of using an LLM chain, passing it an LLM, passing it a prompt, you can just use a pipe and create a chain there, right? So I can say joke template and pass in that LLM, and then say joke invoke. In this case, I'm passing a kind of a JSON object saying that my joke type is dad joke, and here my subject is Python. Why did the Python developer get a dog? To have a tail. The tail recursion, right? So now let's talk about something a bit more complex. You are using a chat prompt. With chat prompt, you can say my system is supposed to be this. In this case, I'm saying the system to act like a food critic. I'm telling the system to be a food critic and kind of provide, criticize on a particular restaurant, or give me some ratings, or let's see how it kind of answers to my question. And human would be asking a question. So you have a runnable here. We have a prompt, we have LLM, and we have a string output parser. All that needs to be done is take those chunk as a stream and print the output. So the question I asked was, tell me about the Indian restaurant you visited last night, right? So is it a bug or feature we were discussing in the previous talk, right? Is it hallucinating that it went to a restaurant, or is it taking some cross-reference of an Indian restaurant? Let's see what it responds. It says that the Indian restaurant I visited last night called the Spice House, I don't know about it, must be good. It says the food was delicious and the service was excellent. I would highly recommend this restaurant to anyone looking for great Indian meals. It's what it looked like, I guess. So yeah, so it is pretty good at imagining a restaurant and criticizing it, which is great. We can get even more specific and say, this is the restaurant that you need to talk about, and let's see how that can be done. If not in this example, have a contrasting example later on. So the other chain is in terms of the transformation chain. So far, we have been seeing examples where LLMs are trained on certain set of data and they can't surpass that, right? Say if it's fine-tuned to a particular data set, it can't go beyond that. Its knowledge is kind of confined to that. So with transform chains, you can put an extra function to it and play around with the existing data and make it better. In this case, I'm using a translate function. All it does is takes the text in English and translates it to Spanish, right? So here's an example, prompt template from template, reply with the translated text, and I create a transform chain. I have a lambda here, which basically takes the text and pass it to the function transform function, and then passes that to the prompt and that to the LLM, and finally the string output parser. So let's see what happens. I passed in hello world, and it did respond in Spanish, right? Any native speakers who can help me with the pronunciation? It's ES? Yeah, it's Italian. Yeah, Spanish. Did I give ES? Or what was the lang I gave? Okay, ES. All right. Hola mundo. So ES is Spanish, right? Yeah, so it got confused. All right. So one of the members in the audience said it's Italian and not really Spanish, right? So all right. So but we do know that we can hook in functions and play around. Maybe the classic example would be like the reversing the text or things like that, right? So, but this is not part of the hallucination. This is part of the translator plugin itself, right? It's not LLM which is playing with it, right? So now we have Langchain memories. Memory, of course, as the name says, it can maintain the context and answer based on it. So we create a memory. In this case, we're using conversational buffer, and we are saying the memory key is chat history and return message to be true. And I've installed DuckDuckGo search. DuckDuckGo is the free and open source alternative search engine to avoid search bubbles and things like that. So I'm again using chat models. I'm using chat Google PaLM. In this case, from agents, I'm getting tool, agent type, and from the tool, I'm getting DuckDuckGo search. So we'll see what agents and tools are and how kind of they gel well, right? So I created a chat LLM here, and I created an instance of DuckDuckGo search run, and then I created a tool. I say tools is an array of tools, basically. So you can create multiple tools there and chain it with your LLM. In this case, I am saying tool name is DuckDuckGo search, function is DuckDuckGo.run, and description is search.ddg, and I create an agent here. For agent, we just pass in the tool, and then LLM and say the agent type is so and so. In this case, it's conversational, and I say memory is set the memory to the conversational chat memory that we created at the beginning. So I set the memory, so then now the chain kind of remembers the context. Let's see how well it is remembering the context. I'm saying who is Hemanth HM. So it's the agent is the agent executor started, and then it created this JSON with action type, and there is observation. So that's what basically agents do, right? They kind of observe and see what tool should I use. Should I use a search here, or should I just use like text completion, right? So it kind of decides on the fly, and based on the observation, it picked up saying that, hey, I need to do a search. So it went ahead, did a search, and came back with the final answer. It said, Hemanth HM is a senior software engineering manager, PayPal, is a well-known figure in Node.js, blah, 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 and all of that, right? So it kind of picked up from DuckDuckGo search value, and it also figured out smartly that it needs to use the DuckDuckGo search tool based on the prompt that I passed to it. Now let's see whether it can remember the context. I'm asking what is his website, right? I'm not giving any name or anything here. I'm just saying what is his website. So it did figure out that it needs to do the DuckDuckGo search, and it came back with an error. So let's run again, right? So the error was the chat LLM didn't give any response. Basically, it said the chat LLM should have at least one response is what it was saying previously. Now it did. In this case, it's saying my website is hemanth.hm, but it's h3man.com, close enough. But it did get information based on my context, who I am and what I do and things like that. And the Langchain experimental is as the name says, it's an experimental module. Let's see the different experimental features it has. The cool chain that has its PaLM. PaLM is for program-aided language models. In this case, you can import PaLM and ask it to create a math prompt. And math prompt, I'm saying, hey, John is twice as old as Jim. This will bomb. I wanted to demonstrate how it would bomb. It created a Python code here, and it says Jim age is not defined. But it still kind of creates the Python code. It's experimental, and I did try asking it like, John has 2 pens and Rob has 3 pens. How many pens together? It does good. We are 2 minutes on time, so I'm on track. So we have other example of LLM bash chain. It can create a bash script for me. I create a bash chain and say from LLM, that LLM, and then pass in the prompt to it. I'm saying, please write me a bash script to print today's date. Today's date is apparently 12/4/2023. And it did give me the bash script for that, right? So that's experimental Langchain. Quickly, I'll run through this example here in Langchain, using Langchain, how you could kind of query your document, right? In this example, I'm using Langchain and Google PaLM, and then I'm using document loaders to load unstructured URLs. In this case, I'm loading an URL that's a very famous white paper on why functional programming matters. I use that. I create a retrieve Q&A from chain. Q&A is basically saying I'm asking set of question answers. And so for this PDF, I'm asking summarize this paper in 8 bullet points. So it would go ahead and summarize that paper for me. As you see, it's just like a couple of lines of code where I'm using unstructured URL and creating a vector store out of the document and then querying that vector store. I'm using a recursive character splitter with a chunk size and a chunk overlap of 0. And then you could go ahead and ask a question to summarize that paper. It does summarize. So it's that easy for you to use any PDF document that you have and summarize it or ask questions to it. The other example I have is in terms of YouTube query. It does a similar thing. It takes a YouTube URL, creates a transcript out of it, and then you can ask questions on that transcript. In this example, I'm using this video, and I'm asking it to summarize the video. It says this video is about Hemanth HM talking about so-and-so, and then I can ask other set of questions on it, and what are they talking about open source about in this video. It does talk about that. And Llama Index also provides a similar toolkit. In this case, we are using a simple web reader. I'm passing my website to it. And for service context, I'm passing a BAAI. I did face issue with passing the PaLM model. I've created a GitHub issue on that. But I'm using the BAAI here as the embedding model. And same thing, the vector store index is created from the documents. And then I create an index on it and query it. I'm saying summarize the website in Markdown. It goes ahead and summarizes my website in Markdown format. I can use Llama Hub. Llama Hub gives us all the parameters required and do the similar thing on the UI. And finally, I can talk to the database using Psycho PG. I'm talking to a PG SQL that's hosted on Elephant. I can query it. It would come back with response, creating a query for database. I'm done with my time and be happy to discuss more outside. Thank you, everybody.